The National Electrical Code does not explicitly prohibit the use of metal staples when anchoring non-metallic sheet cable, often referred to as NM cable, to the side of framing members in residential wiring. However, there are several critical considerations and requirements outlined in the NEC that must be adhered to when using metal staples for this purpose. The primary concern revolves around ensuring that the staples do not damage the cable sheathing or insulation, which could lead to electrical hazards such as short circuits or ground faults. Article 334 of the NEC, which covers NM cable, provides specific guidelines for its installation and support. Section 334.30 specifically addresses securing and supporting NM cable. This section mandates that NM cable be secured to framing members using straps, staples, or cable ties designed and installed in a manner that does not damage the cable. This requirement underscores the importance of using appropriate staples and installation techniques. When selecting metal staples for NM cable, it is crucial to choose staples that are specifically listed and identified for use with NM cable. These staples are designed with smooth, rounded edges and a broad bearing surface to minimize the risk of damaging the cable sheathing. The listing and identification of staples ensure that they have been tested and evaluated for their suitability in securing NM cable without causing harm. Furthermore, the NEC emphasizes the proper installation of staples. Staples should be driven straight and flush with the framing member, without excessive force that could crush or penetrate the cable sheathing. It is essential to avoid overdriving the staples or setting them at an angle, as this can create sharp edges or points that could damage the cable over time due to vibration or movement. In addition to selecting and installing staples correctly, it is also important to consider the spacing and support requirements for NM cable. Section 334.30 of the NEC specifies that NM cable be supported and secured to intervals not exceeding 4½ feet along horizontal runs and within 12 inches of boxes, cabinets, or fittings. These requirements ensure that the cable is adequately supported to prevent sagging or strain, which could also lead to damage over time. The type of framing member to which the NM cable is being secured can also influence the selection and installation of staples. For example, when securing NM cable to wood framing members, it is important to use staples that are long enough to penetrate the wood adequately but not so long that they protrude through the other side, creating a potential hazard. When securing NM cable to metal framing members, it is essential to ensure that the staples are compatible with the metal and that they will not corrode or damage the framing member. The NEC also addresses the protection of NM cable in specific locations where it may be subject to physical damage. Section 334.15 outlines the requirements for protecting NM cable where it is exposed to abrasion or other forms of physical stress. In these locations, the cable may need to be installed in conduit or protected by guard strips to prevent damage. It is important to note that while the NEC does not prohibit the use of metal staples for NM cable, some local jurisdictions may have additional requirements or restrictions. It is always advisable to check with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. Moreover, best practices in electrical wiring often go beyond the minimum requirements of the NEC. Many experienced electricians prefer to use non-metallic staples or cable ties for securing NM cable, as these materials are less likely to damage the cable sheathing and provide a more secure and reliable installation. Non-metallic staples are typically made of plastic or nylon and have a smooth, rounded surface that minimizes the risk of abrasion or penetration. Cable ties are also a popular choice for securing NM cable, as they are easy to install and provide a flexible and adjustable support system. When using cable ties, it is important to choose ties that are specifically listed and identified for use with NM cable and to ensure that they are installed in a manner that does not over-tighten or damage the cable. In summary, while the NEC does not explicitly prohibit the use of metal staples for securing NM cable in residential wiring, it is essential to select and install staples that are specifically listed and identified for use with NM cable and to follow all applicable requirements for spacing, support, and protection. It is also advisable to consider using non-metallic staples or cable ties as a best practice to minimize the risk of damage to the cable sheathing and ensure a safe and reliable electrical installation. The NEC serves as the cornerstone for electrical safety in residential, commercial, and industrial settings. It is regularly updated to reflect the latest advancements in electrical technology and address emerging safety concerns. Staying informed about the latest edition of the NEC and any local amendments is crucial for ensuring compliance and promoting electrical safety. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 of the NEC covers general requirements, including definitions, wiring methods, and installation requirements. Chapter 2 addresses wiring and protection, including overcurrent protection, grounding, and bonding. Chapter 3 covers wiring methods and materials, including specific requirements for different types of cables and raceways. Chapter 4 addresses equipment for general use, including appliances, luminaires, and motors. Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and places of assembly. Chapter 6 addresses special equipment, including electric signs, elevators, and electric vehicles. Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and communication systems. Chapter 8 covers communication systems, including telephone, data, and cable television systems. Chapter 9 contains tables and examples to aid in the application of the NEC. Within each chapter, articles provide more detailed requirements for specific topics. For example, Article 334, as mentioned earlier, covers NM cable in detail, including its uses permitted, uses not permitted, installation requirements, and ampacity. Sections within each article provide even more specific requirements for particular aspects of the topic. For example, Section 334.30 addresses securing and supporting NM cable, while Section 334.15 covers protection from physical damage. Understanding the structure of the NEC and how to navigate its various chapters, articles, and sections is essential for electrical professionals and anyone involved in electrical installations. The NEC is not a design manual, but rather a set of minimum safety standards. It is the responsibility of qualified electrical professionals to design and install electrical systems that meet or exceed these standards. In addition to the NEC, other standards and regulations may also apply to electrical installations, such as those promulgated by underwriters' laboratories, the National Fire Protection Association, and state and local governments. It is important to be aware of all applicable requirements and to ensure compliance with them. Electrical inspections are an important part of the process of ensuring electrical safety. Electrical inspectors review electrical installations to verify that they comply with the NEC and other applicable standards. They may also conduct inspections during the construction process to identify and correct any deficiencies before they become hidden behind walls or ceilings. If the electrical installation fails to pass inspection, the inspector will typically provide a list of violations that must be corrected. It is the responsibility of the contractor or homeowner to correct these violations and to request a re-inspection. Failure to correct violations can result in fines, penalties, or even the disconnection of electrical service. Electrical safety is a shared responsibility. Electricians, contractors, homeowners, and inspectors all play a role in ensuring that electrical systems are installed and maintained safely. By understanding the NEC, following best practices, and working with qualified professionals, it is possible to create electrical systems that are both safe and reliable. The importance of proper grounding and bonding cannot be overstated. Grounding and bonding provide a low impedance path for fault currents to return to the source, allowing overcurrent protective devices to trip and energize the circuit. This helps to prevent electrical shock and fire hazards. The NEC contains detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods of connecting grounding conductors to equipment and enclosures, and the requirements for grounding electrodes. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The NEC specifies the types and sizes of overcurrent protective devices that are required for different types of circuits and equipment. Arc fault circuit interrupters, or FSIs, are a relatively new type of overcurrent protective device that is designed to protect against arc faults, which are a common cause of electrical fires. FSIs are required in many residential circuits, including those that serve bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are another type of overcurrent protective device that is designed to protect against ground faults, which can cause electrical shock. GFCIs are required in many locations where there is a risk of exposure to water, such as bathrooms, kitchens, and outdoor areas. Electrical safety is an ongoing process. Electrical systems should be inspected and maintained regularly to ensure that they are operating safely and effectively. This includes checking for damaged wiring, loose connections, and overloaded circuits. Homeowners should also be aware of the signs of electrical problems, such as flickering lights, warm outlets, and burning smells. If you notice any of these signs, you should contact a qualified electrician to investigate and make repairs. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock and other hazards. Always turn off the power to a circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, you should hire a qualified electrician to do the work for you. The NEC is not a static document. It is updated every 3 years to reflect the latest advancements in electrical technology and address emerging safety concerns. Staying informed about the latest edition of the NEC is essential for electrical professionals and anyone involved in electrical installations. The NEC is available for purchase from the National Fire Protection Association and other sources. It is also available online through various subscription services. In addition to the NEC, many other resources are available to help you learn about electrical safety. These include textbooks, training courses, and online resources. The National Fire Protection Association also offers a variety of educational materials on electrical safety. By taking the time to learn about electrical safety, you can help to protect yourself and others from electrical hazards. Electrical safety is not just a matter of following the rules. It is also a matter of using common sense and good judgment. Always think before you act, and never take risks when working with electricity. If you are not sure how to do something safely, ask for help from a qualified electrician. Electrical safety is everyone's responsibility. By working together, we can create a safer electrical environment for ourselves and our communities.